Okay, here are the notes for lesson 3.3, focusing on properties of logarithms. What we're going to do here today, pretty short lesson, is look at the change of base formula to solve any logarithm. And then we're going to look at three different properties that will help us either combine logarithms or expand logarithms. And we're going to start here with the change of base formula. Now the change of base formula is pretty simple. We see a lot of times logarithm base something of x, okay? And if we want to figure out what that is, because our calculators can only do base 10 or the natural log. So when we have weird bases, it doesn't work. But with this change of base formula, it can. So imagine here that this is log base 4 of 10, okay? Well, then we just can choose any base, and this is where it'll be nice with base 10 and base e, because we can do that in our calculator. But this could even be log base 2 of my x, which would be 10, and then it would be log base 2 of 4, and I can divide those two and come up with my answer. And so I can use this, and what I'm really going to be using here today is base 10 and ln, because I can do those on my calculator. Okay, so the same thing applies though. If that was the original function was log base 4 of 16, then I would have log base 10 of 16 divided by log base 10 of 4, which I can plug into my calculator and I can solve. So let's see that example. I am actually going to change this to 16 so it follows what I just did. And I'm going to use log base 10 in my change of base formula here. And so what I end up having is log base 10, which I'm just going to leave blank because that's what we do. So log of 16 divided by the log of 4. And I can plug that into my calculator, and by doing so, I get that this is equal to 2. Okay? And if I wanted to check my work here, this one's actually kind of nice because I could set this equal to y. Because we've done ones like this before. Set this equal to y, and what I have is 4 to the y equals 16. Well, using, knowing what, y equals here would be 2. Okay, I could also got the same base and done 1 to 1, but I also just know y had to be 2 because 4 raised to the second power equals 16, and that confirms what I saw here. Okay, this next one I'm going to use the ln change of base because I'm going to show you that they're kind of interchangeable, that they both work. And so ln is just log base e, and that's why it does work, and so this becomes the ln of 12 divided by the ln of 2, and I got to plug that into my calculator. And that gives me 2 I'm going to run out of room right there. I'm going to write it below. That gives me 2.85 as an answer there. Oops, sorry, I must have put it into my calculator wrong. I think I had it set up wrong. So this is actually 3.58. That is the answer. I just plugged into my calculator wrong. It just goes to show that using parentheses is important. So ln of 12, and the 12 was in parentheses, divided by the ln of 2, and the 2 was in parentheses. Now here are the properties that I'm really going to focus on here today that are going to be how we combine and condense. We know this one already. We know this inverse one, like a to the 0 equals 1. And so then log base a of 1 equals 0. We know this inverse property from a previous lesson. These are the ones we're going to focus on though. So when we have log base something of multiplication, we can split it into addition of the two things that were being multiplied. Okay? Same thing goes for the natural log. Here we have division, and division breaks down into subtraction, or vice versa. Subtraction turns into division. Same thing goes for natural log. The power property here, you see log base a of u to the n power. You're allowed to bring that n down in front, and you're allowed to do that with the natural log as well. So let's see some examples. So we have log base 9 divided by 300, and what this can turn into would be log base 9 minus log base, sorry, it's log base 10, but I'm just leaving it as log because when you don't see anything, it's log base 10. So log of 9, log of 300, and I'm doing subtraction because this was division here. And then I can simplify this down if I want to. And I can just plug it into a calculator, log base 9 minus log base 300, and I got the answer of negative 1.52. Next one, I'm going to erase what I have because I wrote so big that I want to give myself more space for B. And so this one here, again, it's division, so I can turn it into subtraction, and I get the ln of 6 minus the ln of e to the second power. Well, this we can keep simplifying. This turns into the ln of 6 minus 2 to the ln, or 2 times the ln of e using the power rule, because it had a power up here that you know can bring down. And then I know that the ln of e really turns into 1, and so this is the ln of 6 minus 2 times 1, which is ln of 6 minus 2. And I could get the decimal, but for this one, I'm going to leave it as this. I could plug that in my calculator, but again, I'm just leaving it as that. Let's see some more here. Okay, what I have here is the log base 5 of 5 to the 1/3 power. Okay, because the cube root is the same thing as the 1/3 power, so I'm going to bring that down. So this is 1/3, bringing it down using the power rule. Log base 5 of 5. And from a previous lesson, I know log base 5 of 5, that's going to equal 1. So this turns into 1/3 times 1, which equals 1/3, and that would be your answer. Here we are going to actually kind of use the opposite, and we're going to see that this is a subtraction, and we're going to turn it into a division problem. There is other ways to do this problem, but I want to combine this. I want to show an example of combining. And so this is going to be the ln of e to the 6th divided by e to the 4th. Sorry, e to the 2nd. Read it wrong. That division is like, when you have division with exponents, it's like subtraction. So this becomes the ln of e to the 4th, because 6 minus 2 is 4. The power rule tells me this is 4 times the ln of e. The ln of e equals 1, so this is 4 times 1, which equals 4, and that is my answer. Another way you could have done this is you could have seen this as 6 ln of e minus 2 ln of e, and then you could have seen this as 6 times 1 minus 2 times 1, and you would have got 6 minus 2, which equaled 4 as well. Either way would have worked. Here we're going to try to expand this, and so we have a bunch of multiplication here, and so this is going to be log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Do one more step. I got to use the power rule here to bring this 3 down. So my final answer when I expand it would be log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And that would be my complete expansion there. Here we're going to expand this one. We have the natural log of the square root of 3x minus 5 minus the natural log of 7. This can turn into the natural log. Another way to see square root is 3x minus 5 to the 1/2 power minus ln of 7. Now I can see it as a power. I can use the power rule. So this is 1/2 ln of 3x minus 5 minus ln of 7. This is where the problem comes to an end because I can't expand this anymore. Okay? There is no other property I can use, so my answer here is this. Let's look at a condensing one. Okay? So this can turn into the log base x to the 1/2 plus log base x plus 1 to the 3rd power. Just using the kind of inverse, not inverse, the opposite of the power rule, or going the other way with the power rule is probably the right way to say that. And then what this turns into, let's change these into square roots and cube roots. So x to the 1/2 is the same thing as the square root of x, plus log base x plus 1 to the 3rd power. And then since this is addition, we can turn this into multiplication, and we can get log base 10, really, of square root of x times x plus 1 cubed. And that would be combined into one logarithm. A couple more examples, and then we'll be done. We have this being the ln of x plus 2 squared minus the ln of x. And I got then the ln of x plus 2 squared divided by x, and that would be my condensed version. One last one here. We got to do the things in the bracket first, and then at the end we'll use the 1/3, and so this becomes the log base 2 of x times x plus 1, and 1/3 is still out here, so now we got to use 1/3 at the end, and this is log base 2 x times x plus 1, and that whole thing is raised to the 1/3. And that would be, again, the condensed version. The next slide has the homework on it, but I already posted the homework for today, so make sure you check the stream to see what the homework is, and then ask questions on the homework or after you watch this video lesson to maybe answer more questions about condensing and expanding logarithms using our properties.